Okay, good afternoon to everybody. Firstly, good afternoon, Professor Aaron. It's been a while since we last met. To Professor Teo, Associate Professor Chai, thanks for the invitation. To the esteemed speakers, and also to Professor Lim, my ex-colleague from Global Foundries also. And most importantly, to the students who are here and also watching. So today I'm going to give you an overview of the challenges and most importantly, the opportunities in semicon. So to a certain extent, I'd like to thank Prof. Aaron. He kind of gave us a snapshot of a certain portion that I'm going to present later on, but I'll give you a context of where I see as an opportunity today, not just Singapore, but globally in terms of where we are. So firstly, I will give you an overview first of global, where it's a trend be the past 20 years. I'll bring us back to Singapore from a Singapore context. What is Singapore semiconductor industry landscape looking like? Before I go into some of the hot topics of the industry, one is the environment. Secondly, everybody's talk about today is on Gen AI. And finally, before I give you a final thoughts about where the industry is heading into the decades. So the semicon industry is pretty interesting. It is one of the very few industry that continues to grow. Unfortunately, despite the pandemic that we saw over the past years, it's an industry that still grows. In fact, the buzzword that we've been talking about the past 2-3 years is that this industry is set to hit into $1 trillion by the end of this decade. And despite the slowdown that we see last year, we still have about 600 over billion of sales in 2023. And this year is expected to be a better year than what we saw last year. In fact, in 2020, Boston Consulting Group, together with our sister trade association, SSIA in US, they made a study and they showed that over 50% of the growth over the next decade will be in Asia. And this was actually the start of Biden's administration's policy into the CHIP Act. This was the beginning to show the importance of focusing and investing into the semicon. And since then, you read the news. Every country is looking at semicon today, not just from economic lens, but also from a national security lens. Yeah. So if you look at the growth area over the past decade, Asia has picked up. Okay, and if you look at the pink area, China is one of the areas has been growing. I know today the talks about the restriction, the love affair between US and China, unfortunately, is happening. But you all must understand also that bulk of the semicon capacity is not in the bleeding edge area. It's about making chipset that really exists 20-30 years ago in terms of technology, your materials for IoT, connecting your projector, your refrigerator. So these are in mass production in countries like China. Now, that said, beside China, there are also emerging countries, but it's good to say that Singapore, we've been around for 55 years now in this industry. In 1968, we started this industry. We have grown since then. We produce about 11% of the global semiconductor sales, and I'll elaborate more on that later on. Now, over the past year, we have seen technologies like 5G. Just at the onset of the pandemic, we saw technologies like 5G being rolled out. We now see over the past year, Gen AI. These are all technologies that are driving the demand for semiconductor further. Yeah. So if you look at where the global market is for semiconductor chip, PC and computer remain as one of the major consumption in communication also. But one of the growing area that we've seen today is automotive. Today, not just the electric vehicle. Every single vehicle, your your internal combustion engine cars, there is some form of chip inside already. It could be just your infotainment. It could be your braking system. But now it's starting to grow in that space. And of course, one of the areas you start to see is also Gen AI and everything else. Yeah. So you will hear the news over the past 3 years. Unfortunately, there was also chip shortages. And this was also a wake-up call to people. Our society is becoming more digital moving forward into the future. As we move into a more digital age, the demand for semicon has to grow, correct? And with that, we saw during the onset of the pandemic when it started, most of y'all were home-based learning, studying from home. Your parents were doing work from home, and suddenly there's a need to upgrade your iPad, your iPhone, your display. There was a surge in terms of demand for the semicon chip. So for the students, I always quote this very simple example. How many of you all struggle to get your PlayStation 5? Correct? And guess what? Today, PlayStation 5 stock is available is because of Singapore. There's one company called AMD that has a solution that actually creates the supply for the chip that then met the supply for the PlayStation 5 also. So this was a wake-up call for many countries. If you are not part of the supply chain for semicon, there may be a national security concern because everything in our life today is dominated by digital, by semiconductor already, which is the reason why we are seeing lots of investment in this space, not just from US, but everywhere. So if you look at what's the impact of semiconductor in terms of the national GDP, if you just look at the bottom of the scale for the foundry level, is estimated to about 120 billion in terms of value. But if you goes up to the top, as you progress into the semicon era, if you go into the electronics, the end product like your Apple, and subsequently your so-called supporting ecosystem for the semicon, this has a significant impact to the global economy. And that's how significant semiconductor is, not just to a country, but global economy too. So the importance of semiconductor is not even in debate today. Now the question is, how can any country get into the supply chain, get into the table with semiconductor, yeah? So now let me bring us back to Singapore. Where is Singapore in terms of the semiconductor? You'll see we celebrated the 55th anniversary of our industry last year. We have been around for 55 years. 1968 we started. Back then, Lee Kuan Yew and his team brought in the test and packaging group. Since then, we have progressed through the decades. In the in 1980s, we actually have our very first foundry chartered semiconductor. And since then, we have advanced in terms of R&D also. Today, we have easily over close to 1,000 companies and supporting companies in the space of semiconductor industry. From manufacturing standpoint, Singapore GDP covers about 22% in terms of advanced manufacturing, of which 7% actually contribute by semiconductor manufacturing alone. So if you look at that, 55 years of history, where are we? We are actually covering all aspects of the ecosystem, not just at 5 o'clock, your manufacturers, but if you look at your 10 o'clock, your equipment manufacturers out of US, I'm very proud to say that Applied Materials has a very strong presence in Singapore. And we produce a huge number of equipment for the semiconductor manufacturing also. If you look at 10 o'clock, you have your materials, your chemical group that is coming in. And most importantly, the fabless guys are also in Singapore. But the most important part is actually at your 12 o'clock, which is your RI, your research institution, such as your A-Star, IME group, most importantly, NUS, NTU. We must continue to go out the value chain, which means R&D is very important in our strategy for semiconductor, yeah? So Singapore, like I mentioned earlier, we are a significant player. Our total sales for semicon is in the ballpark of 11 to 12%. This is somewhat equivalent to EU. Now, I would say that our manufacturing of chip alone, we produce about 6 to 7% of the global chipset. And just the 5G filters alone, Singapore is one of the major producers of 5G filters, just by 2 companies in Singapore. We produce about a third of the global 5G filters. That's how significant we are. But more importantly, it's not just a traditional semicon manufacturer. It is the ecosystem that supports the semicon. We are significantly huge in this space also in Singapore, yeah? And we support not just Singapore, but regionally. So if you look at where are the growth area in mid-2000, when Steve Jobs brought out the first iPhone, that was a growth area, mobile. Then you follow up by Google, Android, everything else. Today, like I mentioned, your automotive is driving the growth. IoT, Internet of Things, now is AIoT already, your wearables, your entertainment system, everything else. But more importantly, it is also your AI. Now, AI is still in debate. The growth impact is relatively small, but there is a trickle-down effect beyond just traditional so-called chip manufacturing. I'll elaborate that later on also. So why is it that Asia is attractive to semicon investment? Not just in Singapore, but Taiwan. They have a very rich history in terms of semicon already, large talent pool. That's the most important when it comes to semiconductor. Secondly, our operating costs in Asia is lower than what we see in the West. And more importantly, is the ecosystem, like I mentioned so many times, that supports our industry. Ecosystem like your aircon servicing, your glove, your mask, these are things that actually helps the semicon industry and is significant here in Asia. But Singapore has an added advantage. Firstly, is our stable political backdrop, our good IP protection laws, and more importantly, the strong tripartite support between the government, the labor movement, and the companies. So you don't see strikes, you don't see all these things, you see more of collaboration on a win-win situation basis. Yeah. So investment continue to come. You see that over the past years. So now let me touch a little bit about AI, especially Gen AI. I won't go too much into the wordy tones of it, but more importantly, you all should know what is Gen AI. I know there are teachers, when I speak to secondary school, they are saying that they ban the kids from using Gen AI. Actually, at home, I'm asking my kids to learn ChatGPT because it is the future. We have to embrace it. We need to know how to use it, but more importantly, how do we live with it? So Gen AI is in, and if you look at every images that I create here, actually it's by Gen AI, it's by DAL-E. In fact, I used to have more boring images, but I used DAL-E to enhance my presentation voice also. So if you look at the impact to semicon, now, when we talk about Gen AI over the past year, the one name you hear very often is NVIDIA, which is true. When you started off with Gen AI, the computing power is key. You need the strong computing power. Very soon you hear from AMD, my friends in AMD will be announcing something also. But when you have your computing power, addressed, what's next? You need to have your memory, correct? So very soon my friends from Micron will be smiling away. In fact, they are smiling already. Then very soon you see data centers all start to pick up. Then what's next after that? You'll become impatient. We need to see faster data transmission. Hopefully the photonics area, your data cable, everything will also improve. So there will be a trickle-down effect. There will be an impact, not just to the computing space of semicon, but everywhere else. So if you look at, I'll skip this part, but I look at the chart here, NVIDIA's value has increased tremendously over the past year. Those who buy their stock, congratulations, okay? But like I mentioned earlier, computing is strong, but the trickle-down effect to memory, to your storage, eventually to networking, there will be a significant impact across the board. Behind all this, semiconductor. So you will see this impact when a technology is introduced. This is the impact, and this is what semicon is the opportunity that semicon can do to embrace and enhance this technology to you all. Yeah. So let me also now touch a little bit about the elephant in the room. Now this is a hot topic, environment. So I always start my thoughts in schools also on environment, but in this aspect, right? Semicon, unfortunately, we play a very contradicting role. While we are the technology that drive solutions such as solar panels, such as electric vehicle, we also leave behind a horrendous carbon footprint. Okay, in countries like Singapore, 96% of our energy source, unfortunately, is natural gas. So no matter what we do, any leaders who stand up there and say we will declare net zero is lying. It's not so simple. So if you look at just TSMC alone, this is in a report from 2022, if I'm not wrong. Just they themselves, they are the largest producer of chip, by the way. I was told there would be a presenter from TSMC here, so it's an honor to have them. So just look at TSMC. They produce about 17 million cars equivalent in terms of carbon emission. I like to use the 17 million because that's something layman's term that we all understand instead of the 15.5 million ton metrics of carbon emission. Imagine that now in context, Singapore, we have about 800,000 cars only. So that's how, in a way, unfortunately, a heavy carbon footprint that we leave behind. So we are a walking contradiction. But if you look at it the other way, we are also the area that has the greatest opportunity when it comes to improvement. So this is where I excite all the environment activists. If you're into this space, semicon is where you want to start. We need your help. Okay, so if you look at ST, for example, 2 years ago, ST Microelectronics together with Singapore Powers, they collaborated to form one of Singapore's largest industrial cooling system, which equates to taking off about 120,000 cars off the road once this is once it starts in commission. You look at most of the factory. This is my S factory, Global Foundries. All these factories today are all topped out with solar panels at the top of their roof already. But here's the opportunity. The panel itself helps about 1% of the energy consumption only. 1%. So those of you who are graduating in the next 4 to 5 years, don't worry, you still got 99% more to help. Okay, so huge opportunity here. Think about it. We have companies in the space of AI, energy savings. They're all coming in big time to support this industry now. Yeah. So I will touch 2 pages just very briefly on Singapore's semicon strategy. So in 2018, 2017, we actually launched the industry transformation map. The concept is basically for the industry to transform, electronics sector to transform, and it's transformed driven by the industry themselves, supported by the government. So they identify trade associations like SSIA to do the job. In 2022, we kind of refreshed this ITM, and we are focusing on 3 areas. We will anchor R&D and manufacturing capabilities for the sector. We will continue to strengthen the talent pipeline to support this industry. And most importantly, on the third one is on sustainability. The last one just say that they identify a neutral party like Chamber of Commerce or Trade Association to drive this for the industry. Now that translates into SSIA's KPI. We focus on 3 areas also. And that's the reason why we are in school talks. We are encouraging more talent. We are encouraging programs like what Professor Lim is doing. We want the talent pool to grow, continue to grow. And that is what we are seeing thanks to IHL like NUS. So now I'll give my final thoughts before I end my talk. It's very similar to what Prof. Aaron has mentioned. It's all about Moore's Law. Okay, so 55 years ago, unfortunately, Gordon Moore passed away last year, but he left behind a legacy that is our guiding principle for the semicon industry. So like what Prof. Aaron mentioned, every 2 years, the chip will shrink, the density will increase, price will drop. So you look at that, in 1956, a 5 megabyte hard disk is brought to the truck by several men. Maybe they have ladies, it will be better, but yeah, men. Now, today, this is a 1 terabyte, micro SD. In fact, I think Micron has come up with a 1.5 already. It's helped just with the tip of fingertips. So here's the question and here's the challenge for all of us. It is true, like what Prof. Aaron mentioned earlier, things are becoming more expensive to manufacture. The technology is getting more exciting, but there is a physical limit to where we can actually achieve. We can't go smaller than the size of an atom. Correct? Today, TSMC is really researching, or maybe they're producing 2 nanometers already. So we are reaching the limit, and where we will be 10, 20, 30 years from now. Now, this is where I think things will become exciting, because this is what I believe. The day will come where I believe the Moore's Law will be augmented. There will be a correction. And this correction is what I call an opportunity. You will hear terms like quantum tech, quantum computing. You will hear terms like no more just advanced manufacturing. Is talking about intelligent manufacturing. You predict the output of the manufacturing even before the material starts in the line. So where are the opportunities? You will start to research more advanced materials. Your packaging needs to be more advanced to meet the needs of the future. Quantum computing is like what I mentioned earlier. You hear words like photonics. We don't just play with electrons anymore. We play with photons now. We combine electrons and photons. And things will be very exciting. But here's the thing. It's no more my time. It's no more, unfortunately, Prof. Ling time. It's actually your time, the students. And this is where I believe the semicon industry will be more exciting, more than ever, in the future. And I'm glad they're all here. It shows a good start. And hopefully this is the start of a very wonderful career for you all and a bright future for humankind because of your research in future also. Thank you.